So this is our Eli Whitney Museum Stormwater Management Project. As you can see on the right is the main building for Eli Whitney Museum. Um, so for the project background and motivation, the Eli Whitney Museum started as a gun factory in 1798, created by Eli Whitney himself. Currently, the site is also a workshop for kids that brings in thousands of students a year. So the site is constantly trafficked. And the purpose of this project is to manage the stormwater runoff and ultimately preserve the quality of the Mill River. Using current existing conditions and flow calculations, the team will determine a solution by creating a visually pleasing yet effective rain garden.
The team has two clients that we will be working with. The first being Bill Brown, who is the site director of the Eli Whitney Museum Shop. Bill has proposed a handful of ideas that he believes will help us with this project. The second client we are working with is Nicole Davis, who is the watershed coordinator. Nicole works for Saves the Sound, and that organization helps improve the rivers in Connecticut, protects the climate and air quality, controls the upkeep in public property, and along with advocacy campaigns. And on the right, you can see our project scope with the red box indicating the parking lot that we are working with. And toward the south end of the picture is the outfall that leads to the Mill River.
So here we have the proposed concept ideas, the design and the CAD files that were made. Starting with the top left, we have the proposed outline of what we think the rain garden should look like and the size of the rain garden. Overall, we're showing 170 feet from each edge of the 25 feet diameter edges, but the rain garden itself will be about 120 feet in length and 15 and a half feet in width is what we're proposing. We show the existing storm drains here in this picture. Moving down to the bottom picture, this is a cross-sectional view. We show a 1 to 2 inch P layer gravel throughout the entire 120 feet by 15 and a half foot rain garden. We're to do a 2-foot bioretention soil mixture for the plants that are shown on the plan view bottom right there. We'll get to, and we'll have some filter fabric, and we'll do 3-inch diameter clean crushed stone. That distance, that depth, it's unknown. Right now, it's going to be 2 feet above the seasonal high water table. And all this is going to be possible when we move up to the top right with the use of the gabions. These allow the water to get into these stone columns that are shown in green on the top right and into the infiltration layer and the permeable layer. And all these together just show what we think the rain garden should look like, how it should be designed, and it's subject to change based on where the water table is. Yet that's going to be determined with a perk test and a few other things to come.
So we created 3 different models within SWIM, which is a stormwater management modeling program. And the models we created is the pre-existing condition, pre-development, existing conditions, and existing conditions with GSI. This picture in the top left is our GSI model. Each model has the same basic components. To the right is our rain gauge, in which we can assign different storms to, like the 2-year, 10-year, and 98th percentile storms, which we ran for the models. The shaded area is the subcatchments. You can see we separated the subcatchments into 4 different areas. 1, 2, and grades 1, 2, and 3 are where the existing grades are, where the water flows into. And then the middle subcatchment is where our suggested rain garden will be. And it's where we assigned our LID model. And each subcatchment, we can assign things like the area, the width, and such. And then on the bottom of the model is our outfall, which we have assigned all of the water to outflow into the Mill River.
So using this model, we are able to model a 98th percentile storm, which is what our proposed design is for our rain garden. As you can see in the pre-development and existing conditions and GSI models that are visually represented down below, we could see a significant difference between 1.2 to 0.03 and a 1.17 difference between our existing conditions and our GSI LID model. And if you look on your top right, we have a visual representation of our 2-year, 24-hour storm, which was modeled because using FEMA floodplain maps, the team is able to determine that a 10-year storm would flood our site. So a 2-year and a 10-year storm were modeled, and you could see the significant differences in peak outflow, which shows that our rain guarding successfully manages the excess rainfall and runoff that our site experiences. Thank you.